Hello, and welcome to another episode of Yummy Data Science. In this episode, we are going to pick up where we left off with analysis of inpatient claims data, and we are going to be doing the same thing with outpatient claims data. So if you want, you can go back and jog your memory by watching this video. I'm not going to be going over the concepts I explained, concepts and pandas terminology that I explained in the previous video. Our goal is to create two files, which constitutes our basic data model for cohort analysis. And one file will be the diagnosis file, and the other file will be the encounter file. So given a diagnosis such as diabetes, you could go to the diagnosis file and you could pull out your beneficiaries along with the year they were diagnosed. And then you could join that with the encounters file to look more in depth at their particular encounters. And the source data is given right here. Is the synthetic Medicare enrollment fee for service and prescription drug events data. And here we are focusing on the outpatient part. And if you're in the concepts that underlie facility claims, you can go and look at this video, Key Elements of Facility, that explains the concepts. So now let's go over to Google Colab and look at the. Here we are at the Google Colab interface where I have the relevant notebook open. And I'm going to be not explaining the concepts I've explained in the previous video. So if anything is unclear, please go back and visit and look at the other video regarding the inpatient claims using Pandas. So I've loaded up my Google Drive where I have the data. And the one thing you'll see different is that I have a PD set option, display max columns. And this, in case you've wondered, sometimes when you're viewing a data frame and it is very wide, Pandas will cut it off in the middle and it will give you a dot, 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 which is very annoying. And you can bypass that by setting up this option. So in the next cell, I'm creating file paths for my outpatient files and some lookup files. And I am then I can see that I'm reading in the lookup files. And there are two lookups. The DRG actually we won't use because in outpatient data, there is no concept of a diagnosis-related group. Diagnosis-related group is an inpatient concept, so we won't be using the DRG descriptor lookup. Although this program was a holdover from the inpatient, so it made its way here. So we read the outpatient data, and using the technique I showed you last time, we outputted the columns and their types, and now we're looking at those columns. And what I'd like to explain to you is what are the differences between the outpatient and the inpatient data sets. So one thing we haven't talked about much is the HICPIC modifier codes. And if I go over in this file, I will see that I've got HICPIC modifier codes in my data set. Go to 100. So I have the diagnosis codes, which I want, the ICD diagnosis codes, but then I also have the E codes or the injury codes, which I don't want, so I'll be dropping those. I have the procedure dates and the ICD procedure, which are surgical procedures. I'll be dropping those as well. And it carries on to page 2. And you will see that here is HICPIC code and here is a modifier code. So although this exists also in inpatient data, our particular file did not have it. So I just want to call it out and explain to you what a HCPCS modifier code is. So HCPCS is simply a procedure code, what was done for treatment, and modifier is codes that give you additional information without changing the definition of the code itself. For example, LT means left side, RT means right side. So it's a fairly simple concept that you're modifying and you're adding additional information. So how is outpatient data different from inpatient data? Well, for first, anything related to admission doesn't exist. So, for example, in our inpatient file, we saw all those flags present on admission. Those are not relevant. Neither is DRG. We talked about that because DRG is an inpatient concept. Source of admission is also not, and length of stay should be one. But there are cases when it's longer because the person is kept in observation or recovery. But you should look at the distribution of length of stay in your outpatient data and make sure that overwhelmingly it is one. And in this data set, ER is not included. And I know that because I looked at the Rev Center distribution. But generally, outpatient data does include ER visits. Inpatient data includes ER visits that then became inpatient admits. So this is a very careful distinction, and I want to highlight that the synthetic file doesn't have that layer of detail. So as before, having looked at the columns and their types, we are converting columns to appropriate data formats. So BenAID, patient ID, should never be a number because it's nonsensical to say what is the average patient ID. So we're going to read it as string. We are going to convert claim from, which is a proxy for the for when the person came to the hospital, and claim through, which is a proxy for when the person left the hospital, into a date format. And here we are also getting the year. And if any of the Python syntax does not make sense, please go back to my previous video on inpatient analysis. I am dropping a lot of columns. So for example, if the columns end with UPIN is an older numbering system for physicians. So we are removing those, or if it starts with E codes, anything that is associated with E codes, injury codes, or procedure dates, we're not interested. So we're going to drop it. And like I said before, I did a distribution of rev code. And the way that this code works, you haven't seen this before, is you have the data frame, and then you have the column of interest in these square brackets. And then you are invoking the value counts method. And this is giving you a frequency distribution of the rev code. And it's telling you that most of them are ones, which is general hospital, and 780 and 789 are dealing with telemedicine. So we are going to ignore the rev center, and we are also going to ignore any claim line information. Remember that rev center is a concept that is related to the detailed portion of the claim. So since we are not interested in the detailed portion, we are going to keep only the header portion, and this we are doing by removing all the claim lines higher than 1, because the claim header portion is repeated for any subsequent lines that are present on the claim in this file. And this is often the case in in health plan databases as well, that sometimes the claim header will repeat. Length of stay is not a concept, but let's check it anyway. So we checked it and we saw that for the overwhelmingly vast majority of the encounters, length of stay was 1, but there is length of stay of 2 and a few 3s. And these, like I said before, are observational recoveries. So now we are making our data model and we are working on creating a wide diagnosis file from the outpatient claims data. And we are going to be taking the BENE-ID, the year, the principal diagnosis code, and all the columns that start with the ICD diagnosis codes. And using the MELT method, we are going to make it into a long data frame. Additionally, we are removing columns where the ICD diag code is not populated. We are dropping the ICD diag call because that stores which column the information came from. So did it come from ICD diag code 10 or 20? And we don't care, so we're going to drop that. And finally, we are removing any duplicative information. So if the same code was present in their principal diagnosis code and it was present in their diagnosis code of 24, then we're going to be not keeping those duplicate rows. And here is another thing that you haven't seen before. If you want to see a row count, you can simply do a length on the diagnosis and you can print it. The reason I'm doing print is if I were to do simply length, and if it were the last thing and the only output, it would print it out. But print with faithfully print out all of your print statements. So that's nice about it. With diagnosis, I'm merging in the ICD descriptor. Usually in a data model or a data warehouse, the descriptors will be kept separately to save space, but in our case, I'm putting those together. Just as I did in the inpatient file, I'm doing a number of diagnoses, and I am then merging that with the outpatient encounters. So here, and finally, I'm saving it to a CSV because my goal is to do this kind of file data modeling with each setting. So inpatient, outpatient, pharmacy, professional, etc. And then collect a holistic picture of the diagnosis and their encounters. So that's where I'm going. Well, thank you for listening to the outpatient video and see you in the next one. Thank you.